So ready to go with the complex unfamiliar questions from paper 1, term 1. You see I've already started underlining here for you. 14, 2, 4, 16, 2 and 8. All powers of 2. Oh look, and it's an index equation. I'm going to need to write everything as a power of 2. What's that equation going to be the equivalent to? Well, the 4 I'm going to write as 2 squared. And this is to the power of 3x plus 1. Multiplied by 16 is 2 to the power of 4, and that's being multiplied by 2 to the power of x minus 2. And then we have 8, which is the same as 2 cubed, and that's being raised to the power of 7x. Well, just step by step your way through this, and it's not actually bad at all, is it? It's pretty nice for a complex unfamiliar. This is going to be 2. 2, that power needs to multiply the 2. When you've got a power raised to a power, you multiply the exponent. So 2 times 3x is 6x. 2 times 1 is 2. Here I'm multiplying, so again I add the powers this time, because multiplication you add the powers. So this is going to be 2x plus 4 minus 2. That's going to be x plus 2. And here I'm going to have 2 to the 21x. I said 21. And wrote 27. That takes some skill. 21x, 3 sevens are 21. Alright, keep going with our rules. This is going to be 2 to the power of 7x plus 4 equals 2 to the power of 21x. Oh look, I've got a base raised to a power and a base raised to a power that are equal. Those exponents, those powers must be equal. I can conclude that. So 7x plus 4 equals 21x. Get my x's together. For 21 minus 7 is going to be 14x. Divide by 14. 4 over 14 is equal to x. We would never leave the fraction unsimplified, so 4 divided by 14, 2, excuse me, 2 over 7 equals x. And we got there without too much effort. There are a couple of lines where you could have saved a little bit of time, but hopefully you can follow that. Not so bad. Nice, easy giveaway, 5 marks. Volumes of 2 cylinders are 480 cubic centimetres and 1,620 cubic centimetres. Find the ratio of their bases, the areas of their bases. Let's find the scale factor of the 2 volumes first of all. So I'm going to do the big divided by little. You could do it the other way, but I like working with whole numbers if I can, and there's a chance that when I go 1,620 divided by 480, then I might get a nice number. Did you get a nice number? 1,240. It's not particularly nice, is it? Well, let's see if we can simplify. Divide each one by 10. That's pretty good. Well, they're both even. That could be 24, 162. Well, that'd be 81. Well, hang on. They're both divisible by 3. 3 goes into 81 27 times. 3 goes into 24 8 times. Now I can't simplify any further, can I? So the ratio of the big divided by the little is 27 over 8. But what do we know about scale factors when we're dealing with 3-dimensional objects? Let's start by thinking about 2 squares. This one has a side length of 1. And that one has a side length of 2. The ratio of their lengths is 1:2. The scale factor for that length, we could say, is 2. What happens if I look at the areas? The area of the first one is going to be 1. The area of the second one, 2 by 2, is 4. Ah, that's right. There are 2 dimensions. That scale factor's been applied twice. Hence, I need to multiply by the scale factor squared. Well, what about if I turned those little squares into cubes? Well, the area of the first one's still only 1 by 1 by 1. Oh, sorry, the area. The volume of the first one is 1 by 1 by 1. The volume of the second one, 2 by 2 by 2, is 8. Why is it 8? Because that scale factor has been applied 3 times. So I could think of this 27 over 8 as the scale factor for one side being cubed. That's 27 over 8. So if I find the cube root, I can find the scale factor for just one length. Cube root of 27 divided by the cube root of 8. You're already screaming at me, you know what the answer is. That's very good. It's going to be 3 over 2. Therefore, for areas, the scale factor equals 3 over 2. But areas have 2 dimensions, so I need to use that scale factor twice. It's going to be 9 over 4. So you could write the ratio as 1 is to 9 over 4, 2.25, whatever you like. There you've got the ratio of the areas of the bases of the cylinders. Well done, we're through paper 1. We'll see you in paper 2. Cheers.